All right, I started with all right again. Cut the video. Okay, there's been a couple of videos in a row that have been fairly challenging. This video is nothing new. Okay, this video is simple. This video, a little tedium, but you can just relax. All right, put on some calming music. Maybe I'll speak in a more relaxing way in this video. In this video, we're going to talk about higher order derivatives. All right, specifically, remember that sometimes we had f prime of x. I can't do this. Sometimes we had f prime of x. Okay, and we also wrote that as dy dx. One was Newton's notation, and one was Leibniz notation. Okay, so we're going to talk about more derivatives. And again, we also wrote this as the derivative of some function. That was the first video we talked about different notations. Well, kind of utilizing this thought, what do you think this is? F double prime of x. F double prime. Well, if f prime is the first derivative, f double prime is what's known as the second derivative. And oftentimes, we write it in a couple of different ways, but this is just the derivative of the derivative. And in fact, there's f triple prime as well, the derivative of the derivative of the derivative, or the derivative of the second derivative. All right, and really, there's as many derivatives as you really want. And there's a class of function called an infinitely differentiable functions. Those are called smooth functions. That's the mathematical definition of smooth. So there's a bunch of different ways of writing the second derivative. Again, d dx of f prime is one. It's also the derivative of dy dx. And then there's a little shorthand in Leibniz notation, d squared y over dx squared. This is kind of shorthand for this. So these are all the same thing. All second derivatives. There's a bunch of notation. Again, this is like the derivative operator. So if we take the derivative of the derivative, we get the second derivative. And this is just another way of writing that. Okay. And again, there are more derivatives. You know, there's a third derivative. That's going to be f triple prime. F prime 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 of x. There's a fourth derivative. Right? But we stop adding primes. Once you get to fourth, you just put it in parentheses. The parentheses implies that it's not an exponent. All right, and then there's the fifth derivative. There's the sixth. There's as many derivatives as you want. Sometimes they don't always exist, but for polynomials, they do. That's another thing. So that's what we're talking about in this video, higher order derivatives. And all it is a little bit of notation and just taking the derivative again. You look at the derivative function, take the derivative of that derivative function, and now you have the second derivative of the first function. So let's get to it. Example. Find y double prime for y equals 2x squared minus 3x plus 1. So first we have to find y prime. Okay? So first we find y prime. And then we take the derivative of y prime. So if finding the derivative wasn't fun enough for you before, you get to do it twice now. So y prime is the limit as h goes to 0. Let's also call this f of x, just to make the notation a little easier, of f of x plus h minus f of x all over h. And again, we know that f of x equals 2x squared minus 3x plus 1. So we'll substitute that in right here. And f of x plus h is the same function. F is the name of the function. So it's the same function, but just with a different input. Instead of our input being x, our input is x plus h. So 2 times x plus h squared minus 3 times x plus h plus 1. It'll be a little messy. We plug that in to the first one. So y prime is the limit as h goes to 0 of that first thing that we wrote down, 2 times x plus h squared minus 3 times x plus h plus 1, minus the whole function, 2x squared minus 3x plus 1. Make sure you use parentheses. Brackets are the same thing as parentheses. I don't know why I used brackets, but parentheses, brackets are both fine. We're subtracting the entire function. We have to subtract the entire function. And all over h. And now, actually even before, but now again, it's algebra time. Hope you love algebra as much as I do. I don't love algebra. I do not like algebra. So let's simplify. The 2 is going to stay there, and then we FOIL. FOIL x plus h squared. X squared plus 2xh plus h squared. So we FOILed that guy. We have to distribute this guy. It's going to be minus a 3x minus a 3h. And we still have the plus 1 from before. And now we have to distribute this negative sign into the function. And that'll be a negative 2x squared plus a 3x minus a 1. And don't worry, the numerator is a little messy, but the denominator is great. I'm going to make a mistake, and I want you to think about what the mistake is. I say, perfect, the h's cancel. Don't write that down. They don't. What's the mistake here? Why can't we cancel? There's one in the top, there's one in the bottom. The answer is you can only cancel fractions if everything is factored. And our top is really messy. Our top needs to be collected and then factored. So we can't cancel anytime soon. I'm sorry. This is going to give us the limit. Oops. The limit as h approaches 0 of the top. Now we have to distribute that to 2x squared plus 4xh plus 2h squared. We can start cleaning things up a little bit. Let's collect like terms. Minus 3. Ooh. I didn't know this was going to happen yet. Minus 3x plus a 3x. Those cancel. Plus 1 minus 1. Great. So we're only left with a minus 3h and a minus 2x squared. Oh, look what's happening. Plus a 2x squared minus a 2x squared. That's great. Oh, but that's it. That's the only thing that's great here. All right, let's cancel, and then we'll. Let me copy this on the next page. Bringing it the limit as h goes to 0. Well, now we can factor out an h at least, right? Factor out an h, and we're left with 4x plus 2h minus 3 all over h, and now it's fully factored. Now we can cancel, and you say, oh, sweet, we're getting close. Limit as h goes to 0 of 4x plus 2h minus 3. Well, as h goes to 0, we can just plug in 0, and this term goes to 0. It's just 4x minus 3. Oh, and then you sigh, give a sigh of relief and say, hooray, we're done. But you're not. You got to do this again. This is the first derivative. This is y prime, remember? We're supposed to find the second derivative. Ah! So we're going to do it all again. It's going to be better this time, though. It's going to be better. As a side note, let's take a little break. What was our function? Our function was 2x squared minus 3x plus 1. Look at the relationship between these two functions. There's a similarity. We'll talk about that similarity when we introduce the power rule. Power rule is going to be great. Once we finally get to some shortcuts for derivatives, y'all are going to be so much happier. That's when you get a small sigh of relief. Although I say that, but I always keep thinking there's a sigh of relief, and then we just get more and more exciting material. Okay, so we found the first derivative. Now let's find the second derivative. Y prime is the derivative. Sorry, y double prime is the derivative of y prime. That's the limit as h goes to 0 of the derivative. Now we're looking at the derivative of the derivative. So this is going to be f prime of x plus h minus f prime of x all over h. Okay. So again, we're going to go off to the side. What is f prime? That's 4x minus 3. What about when we plug in x plus h? It's the same function, still 4x minus 3. F prime is f prime. But now we're plugging in something different. Minus 3. As a side note, sometimes it can be easier, and I probably should have done this. Sometimes it's easier to just simplify off on the side when we're already doing things on the side, right? We're already doing stuff on the side. So simplifying in the blue area is usually going to be easier than simplifying in the white area. Let's do it here. 4x plus 4h minus 3. That's what we're plugging in. That'll make things a little bit cleaner. So this is the limit as h goes to 0 of the derivative. 4x plus 4, that's not a 4. 4h minus 3 minus the function 4x minus 3. Make sure you are subtracting the entire function. All right. That brings us to the next page. This limit, let's distribute that negative and see what we get. 4x plus 4h minus 3 minus 4x plus a 3. Oh, I like to see that. Minus 3 plus 3 plus 4x minus x. We just have 4h over h. Which also cancel. Our limit is just 4. That is the derivative of our derivative. That's our second derivative. So our original function was 2x squared minus 3x plus 1. Our derivative was 4x minus 3. Our second derivative was 4. When we talk about the power rule, one of the things that we're going to look at is what is the derivative of a linear term. The derivative of a linear term is actually just that constant. What's the derivative of 4x? The derivative of 4x is 4. And this part of the power rule, which we haven't introduced the power rule yet, this part of the power rule makes sense. Because what is derivative if it's not slope? Derivative is exactly slope, right? Like if I look at a function and I look at a linear function, let's say this is the function y equals mx plus b. I know the derivative of this. I don't have to use the definition of the derivative. And in fact, we could have taken a shortcut. We could have taken a shortcut right here. Derivative is the slope. What's the slope of the line 4x minus 3? All of you know the slope of the line 4x minus 3. The slope of the line 4x minus 3 is the same everywhere. It's got the same slope everywhere on that line. 4. Derivative is just the slope. So the derivative of a line, oops, I've already wrote that, is just the slope. And eventually we'll talk about what's the derivative of a constant. Well, what's the slope of this flat yellow line? If we have some line, what's the slope of this flat line? 0. It's flat. So those are going to be some of the shortcuts that we're going to talk about in the future. But that's not really related to this video, I guess. A little bonus information, a little fun fact for you. All right, the last thing, I'm not going to do it here, but you'll see it in some of the homework. Acceleration is the rate of change of velocity, and velocity is the rate of change of position. So acceleration is the second derivative of position. Okay. So for example, if y was our position equation, we found that the acceleration is 4. All right. So watch out for that. This will appear. I do have a video coming up after this doing some application problems. So if you want to say, Jason, how can I use this? Stay tuned.